know if I got there. Oh, wait, I'm live. Let's see. Okay, so it's geometry take 3. Let's see if anyone finds it. Weird that I had just done that same process and it wasn't working. Okay, so I should go to my class. Well,
okay, do you think you're live right now?
I think so.
Okay, let me see if I can find it.
Can I share this link?
Oh, geometry take 3. All right, I see you.
Okay.
Oh, no, my voice is on there. I'm going to hang up the phone.
Okay, bye.
Unless you need the phone. Do you need me on the phone?
No, I don't. Okay, bye.
Okay.
Hi, Syed. I'm so sorry that last one got, it said that I had copyright issues and I was, it ended it. So I don't know if people are going to find this. Was it easy enough for you to find? Okay. Hopefully Emily joins us. I don't know if I need to post about this in Google Classroom or not. Geometry take 3. I'm just going to post in Google Classroom real quick. Take 3 live video going on now. All right. All right, we'll get started in 1 second here. All right. All right. I see Mr. Jones wrote about posting the new one. I don't know how to send you a link to the new one, but whatever. Hi, Erica. Hi, Emily. I bought markers, but I don't have an eraser. Hopefully this works. Okay. Well, wonderful. So Syed had already asked a question in our original chat before it got messed up, but he was asking about 2 tangents. Syed, can you write that question again so that we can all be on the same board? I'll make us a circle. I don't know how much of a delay I have in seeing things. Someone could copy and paste this to Wenmaker's classroom. 2 tangents and the arcs between them. Okay. All right, so far, just as we start with tangents, the first thing about a tangent we know is that it only touches the circle at 1 point. And then in the first day's lessons, you guys were learning about how a radius to your tangent is actually going to be perpendicular. So maybe Erica or Emily, can you tell us what did we end up using? What's our favorite thing that we ended up using when you have a tangent to a radius? Oh, I see Emily just posted in classroom. Thank you, Emily. I appreciate you posting that link. All right, Erica, wonderful. The Pythagorean theorem, we love it. So if you know your radius and then you have some other information, right? We'd have to have something else, but keep in mind that this length right here is also our radius, right? So we were able to use Pythagorean theorem. Tom, hi. Good to see you, Tom. Well, kind of good to get to chat with you, Tommy. So we were talking about how we could do Pythagorean theorem, where maybe we know the radius and we could add it here, and then maybe you'd have to have some other information here. But that's not really what Syed's question was. He was asking about if we had 2 tangents. So let's restart here. Okay, so when we have 2 tangents, do my best to draw that. This curved line. All right, so our first, this is wet. This is probably a bad idea to have a wet one. it's leading to not being able to write very well. Well, we'll figure it out. Okay, so here's our first tangent, and then if we have another tangent, and let's say they meet at the same external point, I'm guessing that's what Syed is asking about here. And we want to look at the arcs. So let's start with looking at a problem. I don't know that you guys actually got that far into this already, but let's say that this arc, so an arc is just part of a circle, right? So if we say this arc, all the way around here, it looks a little bit more than half of the circle. Tom, can you give me how many degrees out of the 360 do we want that arc's measure to be? Again, I might have a little bit of a delay from what you guys are typing. See what Tom says. There must be a delay. I'm sure Tom's typed something already. What's he gonna guess? Over 180. That's okay. It looks like it's a little bit more than half of the circle, right? So let's go over 180. Let's say we said 200 degrees. Right now, I don't know that we've really gotten into this part into our lesson so far. But and Mr. Johns claims that that's not backwards on your screen, but if that is 200, then what is this smaller arc going to be? Who can tell me that? Good, 160. Wonderful, Erica. Good job. Oh, Lee's here. Hi, Lee. All right, so 160. Now, this is considered a minor arc since it's less than the 180, and then this is considered a major arc. But they're both called intercepted arcs. So these two tangents that are coming along and hitting our circle, each tangent's only hitting once, but it's dividing our circle into two arcs, the part that's like between them the long way and the part that's between those 2 points in the short way. So that is kind of the two arcs. Now, Syed, can you expand on your question a little bit more? Is that answering like what you meant why there are two arcs with the two tangents, or were you even getting to this part where you were finding this angle out here? While Syed writes his question, I'm going to grab a paper towel because the wet towel that I had was not working. I'll be right back. The angle portion for the bit where the angles meet. Okay, so Syed has a question about the tangents. This is Chloe, everyone. If you want to meet my cat, I've told you that I have the best cat ever. This is her. She's the best cat ever. She's kind of tired though. She's like, why are you doing this to me? Isn't she cute though? Chloe. All right, Chloe, we'll let you go. I'll bring Sophie over in a little bit. Okay, so Syed's question is a little bit ahead, so some of you might not have learned this yet, and that's totally fine. I actually think that I want to pause and do some of the easier ones and build up to this. I know Syed's dying to have an answer to his question, but this is like the last of the ideas that we'll talk about. So let's start with a central angle. So a central angle means you're starting at the center. Oh, Anna's here too. Hi, Anna. If you have two radii forming a central angle, let's say that this angle is something bigger than 90. Let's say it's 100 degrees. Now those two radii intercept part of an arc or part of the circle. So we call that an arc. Guesses on how many degrees that arc is going to be. So an arc is measured. We could talk about a length of an arc, and we'll get to that eventually. But right now, if we talk about just the degree measure out of the 360 degrees, how many degrees do you think that would be if the central angle is 100? I hate this delay. All the answers are flooding in. I just can't see them. But I know what they're going to be. You're going to get it right. This is 100. The arc is, Mr. Johns, this delay is killing me. Mr. Johns, 100 for the win. All right, so central angle and the arc are going to be the same. So if this is 100, our arc is 100. This other part of our central angle here would be 260. So that would mean this major arc is 260. Okay, so that's the relationship. Central angles are as easy as they can be. Now for the next case, we're going to look at something called an inscribed angle. Okay, so an inscribed angle means instead of the vertex of the angle being the center, like we just looked at, so that's called a central angle, okay, right here, instead we're going to pull that vertex all the way over to the corner, or sorry, to the edge of the circle. So this angle right here, where our two sides of the angle are made by what we call chords, right? So this is a chord, and this is a chord. That's called an inscribed angle, okay? Now an inscribed angle, so it's the same as the angle inside the circle. Yes, so Tom, for the central angle, they just match. The angle in the center is the same as the arc. Wonderful. So now when we looked at an inscribed angle, it has a little bit of a different relationship. If this angle were, let's say, 50 degrees, okay, so an inscribed angle compared to a central angle. Let's try to draw both of these maybe on here and see if we can get this a little bit clearer. I'm not loving my numbers that I picked. Mr. Johns, you're probably cringing looking at this. Okay, so let's just say, for example, that this had been a 100-degree central angle. Based on what we had just reviewed and that Tom summarized, this would also be 100 degrees. But now when we pull this angle, we're like stretching it back and it's getting smaller and smaller. So notice the relationship here. Our inscribed angle compared to its intercepted arc, so here's the intercepted arc, that would still be 100, but now the angle is only 50. So an inscribed angle is half of its arc. You could look at it two ways. If you know the arc, you'll take half of it to get the angle. If you know the angle, you'll double it to get the arc. Okay, so let's, I'll struggle with my delay for a second. We'll do an example. Okay, so let's say that out of the 360 degrees all the way around, this arc right here is 40 degrees. The types of questions that you'll see, like what is the measure of this angle? And so we're going to want to think, where is the vertex of our angle? If it's at the center, they match. If it's not at the center, we're going to have to start learning some of these rules. So this one is on the edge of the circle. It's going to make it an inscribed angle. Go ahead and type in your answer into the comments. Good. Natalie is here too. I don't know how to see who's here until you type something. If you're here and you haven't said anything, just say hi so I know you're here. Wonderful. Sophie. All right, so we've got 20 degrees is our correct answer. Your angle is half of your arc. All right, so far, two different rules. Inscribed angles, and we'll review one more time for people who are just joining us. If it's called a central angle, if that's at the center of the circle, if this were to be 95 degrees, then this arc would also be 95 degrees. So they match when they're at the center, But then when the angle gets pulled all the way to the edge of the circle instead, now it's called inscribed, and now it's half of the other one. Hi, Makara. Tom said, so now the outside of the circle doubles the angle inscribed. Yes. So whatever the inscribed angle is, this right here is called an intercepted arc. Intercepted arc. So the intercepted arc is the arc inside of an angle. So the intercepted arc is double of an inscribed angle. All right, great. So I'm trying to think of other things I wanted to mention though before we get on to Syed's question. He's like telling me, why are you taking so long? Just want to go over everything from 12.1. I could just print out our worksheets here. So 12.1, we were using some Pythagorean theorem. Let's do a really quick walk around problem. I just love these. And I'm sad that I'm not there to do this unit with you. I'm actually really bad at drawing these though. So let's see how this goes. Okay, so a walk around problem is where you have a bunch of tangents. Okay, so I can give us some numbers here. Let's say this is 3 and 5, and this is 4 and 5.5. So we can ask like what the perimeter of this quadrilateral is. We don't have any special name for the quadrilateral. We just know for sure it has 4 sides, and every point here is tangent. So when you have 2 tangents, okay, so here would be, for example, 2 tangent segments that both come to the same exterior point. If from this point of tangency, we call that a point of tangency, to this exterior point that's sharing with another segment, if this length is 5.5, what's your guess on this length here? Maybe you already read about this though, but so I'm waiting for the numbers to come in. You can see my son's lovely scribbles all around the edge of this. He's pretty good at it. Oh, wonderful. Me's here too. Hi. Wonderful. So this is 5.5. So we'll do the same thing all the way around. So those 2 tangents were congruent. So 2 tangents that come to the same exterior point for the same circle, they're going to be congruent. So those are both 5.5. These are both 4. These are both 5. And these are both 3. And then we could add them all up and we would get our full. Naomi. Hi, Maya. Oh, we got so many people in here. So we kind of, we'll talk about this as like the ice cream cone. If you think of that as your scoop of ice cream, and here's your cone, those 2 segments are going to be congruent, okay? So that's kind of that idea. So that concludes 12.1. And then 12.2 is about arcs and chords. And we started to get those inscribed angles happening in 12.3. All right, so any last questions about this idea before we move on? Any question about an inscribed angle and its arc versus a central angle and its arc? Do we feel like we have those relationships down? Ready to move on? I can't see your faces. I'm sure a lot of you are like, yeah, keep going, Mrs. Winemaker. You're going way too slow. So I'll just kind of summarize. If this is 75 degrees, this is also 75 degrees. If this is 20 degrees, this would make this 40. So the arc is double of the angle. All right, continuing on. We're finally going to get to the next ideas. Okay, so I think this might actually even be 12.4. So you're getting a little bit of a preview here. Now, if we were to have what we call a secant segment, so a secant is going to hit the circle twice, part of it's inside, part of it's outside, and let's say we had another secant segment. Okay, so these are two secants, both meeting at the same exterior point. Now, an inscribed or intersected arc are the arcs that are inside of the angle. So inside here, we've got this arc. And then if we go to the other points of intersection, we have yet another arc. So there are two. Could be that sometimes both of them are minor. Sometimes maybe one might be major and one minor. There's no necessary rules on that, but we've got these two arcs. And I don't know if I want to give the whole lesson away because you guys are going to be working on describing or studying this in your activity this week. But let's say that this is, if that's 180, right? Half of the circle would be 180. Let's just say this was like, we can just say 80. And this is a lot smaller, 40. So we can find out this angle all the way out here by looking at those these two arc measures that they always relate to the angle. So when it was inscribed, again, a side note, when it was just inscribed, if this had been 80, the angle would have been 40. Really bad little picture there. But now we're taking that vertex. We started at the center. We pulled it back all the way to the edge. The angle got smaller. When we pull this all the way out here, past the edge of the circle, all the way to an exterior point, the angle's going to get even smaller. And you're going to play around with this on GeoGebra later this week. But what's going to happen is that this angle right here is going to end up being half the difference of the two arcs. I don't know how I want to write this concisely. Arc minus arc. So we're going to end up subtracting the arcs. So the difference between these two arc measurements is 40. And then if we take half of the 40, that's going to get us all the way to 20 out here. So you're subtracting the arcs and taking half. It's making it even smaller. So when we started with the vertex at the center, they were just equal. When we pull the vertex to the edge, it's called an inscribed angle, then it's just half. But then if we want to make it even smaller, we're going to subtract the arcs and then take half, which you'll be looking at. So finally, to get to Syed's question, because his is the same rule as that, he was just talking about two tangents. So we're looking at this ice cream cone example. Two tangents, so the tangents only meet at the edge of the circle at one point. And if we knew the measure, so let's go back to saying this was 200 degrees. So that would mean from here to here, the long way, this major arc is 200. That would mean that this minor arc here would have to be 160. So this angle, formed by two tangents, hits the circle at 2 points, one on each side, and it gives us a major intercepted arc and a minor intercepted arc. And if we, I don't know if you can read the green marker very well. I'm sorry about that. If we were to subtract these, the difference of 200, oh, it's actually a blue marker, 200 minus 160 is going to be 40. So 40 is the difference. And then to get all the way to this angle, we're then going to take half of that. So our angle is going to be 20 degrees all the way out here. That is the rule that we're looking at for that one. What do we think, Syed? Is that what you were going at for? After I led you on for half an hour, Syed was the first one on here with his question. And I stalled forever. I'm going to get Sophie. Well, Sophie's on here, but my dog is named Sophie. Okay, Syed said yeah. Sophie, come here. Come here, Sophie. Come here. Come here. Sophie doesn't want to come. She's camera shy. I'll get her. Hold on. Here's Sophie. She's like, I don't like this. Please put me down. She's kind of old. I think she's 11 or 12 now. And she really likes food. Yep. All right. So we answered Syed's questions. What other questions do you guys have? Because if you're understanding what we did so far, I'd say you're in good shape. I'm going to see if my son will make a guest appearance. He's upstairs with my husband. I'm going to tell him, let the beast out. All right. I know she is cute. I've got cute pets. Sophie says, hi, Sophie. We'll see if Justin will come down. But what other questions do we have on these arc and angle relationships? We are going to find out more things than just these being congruent. We're going to start to talk about the lengths of the tangent segments and secant segments, and we have those too. But we still got all week. It's only Monday. You guys are doing really good on your assignments, by the way. I appreciate you putting the time into those. I wish we were all together. I know when they made the announcement that they were closing schools, everyone seemed kind of excited, and now we're realizing what that really means and how much we miss each other. I don't know if Justin's coming. We got 2 minutes. He might not be dressed. Are we going to have a test? I'm not sure what we're going to do. We might just kind of stick with progress checks for now. Yes, he's not wearing pants. Do you want to say hi, Justin? Come here. Is this your whiteboard? Can you say hi?
Baba. Baba. Baba.
Oh, you want your smoothie? Justin, you're at... we had made smoothies this morning. Can you say hi? Hi. Hi. They can't tell that you are only in a diaper. Can you say hi again? Can you say how old you're going to be? Are you going to be 2? 2. Say 2. Yeah? Okay. All right. Well, Tom, we should have coordinated the matching outfits for you and Justin today. Maybe next time. Well, if you end up having any more questions, feel free to just message me. Maybe we could do a Google Hangout. Mr. Johns is going to be, Mr. Johns is going to be doing another live video tomorrow at 10 o'clock. So we're just going to take turns this week. I'm going to do Monday, Wednesday, Friday at 10 a.m. And then he's going to do Tuesday, Thursday at 10 a.m. So it's probably going to be the same thing where I'm probably going to mess up several times before you can find the actual video. But Old Navy is definitely one of our favorites. But if you have any questions, I mean, it's just even some of a review. Maybe some of the things we talked about today you already knew, but now maybe you know them a little bit better. All right. So reach out with any questions. And if I don't talk to you, then maybe we'll chat on Wednesday. Okay. But feel free to reach out. I'll post Mr. John's link tomorrow if you want to join in with him. Okay. Bye, everyone. I'll probably just leave this open for one more minute as Justin plays with his cup and whiteboard. Justin, do you want to say bye-bye?
Baba.
Bye-bye. Bye-bye. Can you wave?
Baba.
Wave. Bye-bye. You love that smoothie, huh? Are you going to be able to get the straw in your mouth? All right, bye, everyone. Good job. Bye-bye. What's this? That's a weird wave. Can you wave like this? You're like the Queen of England. We're trying to use up some diapers that I accidentally ordered. I think they're girl prints. I'm glad it was helpful. Yeah, just come on every day. I feel like if you join in for these half an hours, you'll definitely be Teenage Mutant. You'll definitely be feeling good. All right, I think I'm going to end this. I don't really know how to work, but see you all later.